Hello friends, I welcome you all to my video tutorial. Now onwards I will teach you geometry. Now friends, there has been a wide demand on my blog in order to teach geometry and trigonometry. The point is that I thought of teaching trigonometry first, but in order to understand trigonometry deeply, it is important that we are very much acquainted with the concepts of triangles. And in order to reach to geometry, we first need to do the triangles in whole, complete. A deep analysis of triangles chapter is important, very important in order to understand the topic of trigonometry. So first of all, I will start my course, my videos with geometries, all the topics, all the concepts, all the theorems, and each and every formula which is concerned with the chapter of geometry, I will teach you here. Obviously not a very high level. That much is very much, it will be sufficient from the perspective of your elementary education, school education, also from the perspective of various exams that you are going to face, whether it is SSC, CGL or CAT, anything. So here you will get the best of videos, the best of concepts and the best of teaching methods. So starting the lecture of geometry, now this is my very first, you can say, a video lecture of geometry. So in this lecture I am going to tell you the very basics of geometry. So now here I am going to start with the concept of line. I recommend that if only you want to start from the basics of geometry, then only you watch this video. Otherwise, this first two or three first videos are not very much beneficial for the guys who have done engineering and they are well acquainted with the concepts of maths and geometry. So they do not need to see this thing. If you have not studied geometry first, then this video is for you. After 2 or 3 videos, I will move on to advanced and higher concepts, higher theorems of geometry. There, the lecture will be beneficial for those guys who think that they are proficient in geometry. Otherwise, I will advise you that you watch geometry lectures from the very start. So, starting from the concept of line. Now, if I talk about the broad divisions of the chapter named geometry, there are 2 broad divisions. First, the case that we study in 2D geometry, that is 2-dimensional geometry, and the second case is the case where we study geometry in 3-dimensional geometry, that is in 3 dimensions. Now we know what these 2 dimensions, 3 dimensions are. When we are talking about a plane, then it is a 2-dimensional aspect. When we are talking about the plane and also the height component, then it is a 3-dimensional view. Now suppose that we have a figure like this. What is this? This is a square. What is this? Rectangle. Next, what is this? Triangle. Now, what is the peculiarity of these figures? They have only 2 components. What is the component? Length, breadth. Here also length, breadth, and these are the sides of the triangle. Suppose A, B, and C. Now, this square has been totally shown here. This rectangle has been totally shown on this board. This triangle is being totally shown on this board. Square, rectangle and triangle, each of these figures has been totally shown on this board. What is this board? This board is a plane. You cannot show this, say, as far as the representation, the front representation of this board is concerned, this board is a plane. And by saying that this board is a plane, I am neglecting this width concept of this board. Suppose you see the board in this manner. This is the board. What is this? You can say this is the length of the board. What is this? You can say this is the breadth of the board. What is this? This is the length. And what is this? This is the breadth. Now this is the length of the board, this is the breadth of the board. Now there is also some width of the board here. But in the cases of 2-dimensional geometry, we are not going to consider a width. That is, only those figures which are represented along 2 dimensions are 2-dimensional figures, and those figures that are represented along 3 dimensions are 3-dimensional figures. Now, if we see that we can say that practically everything in this universe is 3-dimensional. Practically everything in this world is 3-dimensional. Now this is on paper, square, rectangle, triangle. Here you need to understand this thing, that this is a square. This is square. This square has been shown on this board. So basically, not don't confuse these dimensions with these three sides of triangle. I said there's all those things that can be represented in the case of two dimensions are two-dimensional figure. So here, some people will say that this triangle is having three sides. So it is three-dimensional. No, it is not three-dimensional because its three sides are manifested on a plane. That is, these three sides are manifested along the two directions. And whatever direction they are showing, it's not of much importance. In this case, I will like to draw a diagram here for you. What is this? This is x-axis. What is this? This is y-axis. Now what is this? This is the x dimension, this is the y dimension. If we draw this figure in 3 dimension, this becomes z. We have seen, many of us, 99% of we guys have seen this figure. Now what is this z? This z is not in this dimension. It has been showed that this z is up in the air. So this is the third perpendicular direction. In order to understand the concept of 3D, you should look at one corner of your room. When you are going to look at one corner of your room, you will very much magnificently, very much clearly see that from that one corner of the room, 3 dimensions are coming out. So those are those 3 dimensions. If you look at one wall of your room, the front face of one wall of your room, you will find a 2-dimensional figure. But if you will look at a corner of your room, then from that corner you will see 3 different dimensions coming out. The very basic thing in order to understand 3 dimensions. Understanding the concept of 3 dimensions is very important from the perspective of the topics of cubes that I will tell you in the reasoning section. So the point is here is that simply speaking, if we are able to represent a figure on a plane, then we will say, that that figure is 2-dimensional. And if we are not able to represent a figure on a 2-dimension and we need 3 dimensions for it, then we will say that that figure is 3-dimensional. Square, rectangle, triangle, as far as the concept of geometry is concerned, square, rectangle, triangles, line, these all are 2-dimensional figures. That is, these figures, when we study the concepts of geometry, they can be represented on a plane, so they are 2-dimensional figures. They are covered under the topic of plane geometry. Plane geometry is also termed as 2-dimensional geometry. I told you 2-dimension means those figures that can be represented on a plane. That is, whether you can say them plane geometry or you can also say them 2-dimensional geometry. Whatever you like. Plane geometry, 2-dimensional geometry. Both the things are correct. Now moving further from this concept, this was a very basic. I hope everybody of you knows it. What is a line? The line is the most basic unit when it comes to study the topic of plane geometry. The very basic thing, the very smallest thing. Obviously dot is the smallest thing, a point is the smallest thing. But after point, line is the most basic unit of plane geometry. Suppose there are many points. I join all of these points. So what it becomes? It becomes a straight line. This is a straight line. Now, in this straight line, there are infinite number of points. So the very first property of a line is infinite number of infinite numbers of points are there. Second, 2-dimensional figure. Already told you. I repeat, these are the concepts which I am covering from the perspective of those guys who do not know even the ABCD of geometry. If you are well versed with these concepts, you can forward the videos and directly jump on to second, third or fourth video. But in the starting, I need to tell you the concepts, the very basics of geometry. 2-dimensional figure. Now, you can say that it lies in one plane, the same thing. Now, if I talk about two lines in a plane, suppose if I talk about two lines in a plane, and if I talk about two lines not in a plane but in two different planes. So, talking about two lines in two different planes is something that we should see by imagination. But as far as the concept of plane geometry is concerned, then plane geometry, you have to see the concepts of line in a plane. So now we are going to look at this thing. Classification of lines. The very first is parallel lines. Second is intersecting lines. The third one is transversal lines. So these are the three types of lines which are going to deal with. Now the first, at this point of time, I am saying that we are talking about coplanar lines. That means all those lines lying in one plane. This is the topic of coplanar lines. Every line is lying on one plane, not on different planes. You need to remember this thing. So, the very first thing I have to tell you about parallel lines. So, what are parallel lines? Now I am deleting this thing. I will tell you these things topic by topic. Line chronology wise chronology. Very first thing, parallel. This is a line. Suppose it is AB. Now I draw one more line. Suppose this is CD. Now what was the basic condition? The basic condition was that whatever lines we are drawing, they are coplanar, that is they are lying in one plane. So AB is lying in the same plane as CD. Now if these two lines are parallel, then the very first property is that these lines are never going to intersect. Parallel lines will never intersect. Parallel lines will never intersect because this AB line is going on in a straight path, this CD line is going on in a straight path, and they will continue going on. So in some books it is also written as that those coplanar lines which never intersect are parallel lines. So this is also there. Those coplanar lines which never intersect are parallel lines. I will write it here. Those coplanar lines which never intersect are parallel lines. These two lines are not going to intersect, so they are parallel lines. These two things are basically the same things. This is the same thing. Now, the perpendicular distance between two inline points. Suppose this is a point. If I draw a perpendicular from this point, perpendicular that is at a distance of 90 degree, and join this point. This is also 90 degree. This is also 90 degree. Suppose this is E. Suppose this is F. Suppose I am jotting a point here G. I draw a line which is perpendicular to it and connect it to its H point. This is also perpendicular. So if the length of this EF is X, then the length of this GH will also be X. So all perpendicular lines joining two parallel lines are same in length. All perpendicular lines joining two parallel lines are same in length. So we are writing the second property. All perpendicular lines joining two parallel lines are same in length. Very basic things about parallel lines. All of us, 99% of you guys will be knowing this thing. But in order to make us a concept, in order to start this thing in the most basic sense, this is the way to proceed. So, I am again repeating it a bit. AB, one line, CD, one line. AB and CD are parallel to each other. That is, they are never going to intersect each other. And the very most and the utmost basic condition is AB and CD are coplanar lines. That is, they are lying in the same plane. So, coplanar lines which do not intersect are parallel lines, and the perpendicular distance between those two parallel lines will always be same. Whether this is here, whether this is here, anywhere. Perpendicular distance between two parallel lines will always be same. Now this is the concept of parallel lines. Rubbing in now. What was the second one? It was intersecting line. Now, just opposite of parallel lines. Two coplanar lines which will never intersect are parallel lines. Now, two coplanar lines which intersect are intersecting lines. Suppose a line AB, CD, and I suppose they meet at this point E. So obviously this E is the intersection point. Now obviously any of the two lines, if they are not parallel to each other, that is, the perpendicular distance between those two parallel lines is not equal, then obviously sometime after extending they are going to meet. Suppose I draw this line. This is one line, and I draw this line. This is another line. Now, if I am going to extend this line here, and if I am going to extend this line here, obviously they are going to intersect at this point. Only if these two lines are in exact line with each other, or in the terms of coordinate geometry I should say, if the slope of the two lines is equal. Now the point here is that I should not take the term slope here, because the term slope is a part of the coordinate geometry and I will take it up there. So at this point of time I will not use the term slope, but I will say that those two lines which are not parallel to each other, that is, if they are extended at some point they will intersect with each other, they are intersecting line. As simple as that. And obviously the definitions will be just opposite to that of the parallel lines, that the perpendicular distances between two intersecting lines will always be different. Now the point here is that a perpendicular distance between two intersecting lines, this is not always true. Suppose this is one line, this is another line. Obviously these lines are going to intersect at this point. But if I draw perpendicular from here and I connect it to this is 90 degree, but it is not important that this will also be 90 degree. So this cannot be a perpendicular line joining two intersecting lines. Obviously. The perpendicular distance will always exist in the case of parallel lines. Transversal line. Now, for transversal line, I need to draw first three parallel lines. Suppose these are three parallel lines, AB, CD, EF. Now these three lines are parallel to each other. This is the sign of parallel. This is the sign of parallel. So I can write that line AB is parallel to line CD is parallel to line EF. This is what I have written. This is the parallel sign. These two lines are parallel to each other. That is, there will be no intersection point of AB with CD or AB with EF or CD with EF. These lines are never going to intersect with each other. That's the basic definition, that these lines are parallel to each other. AB, CD and EF are parallel to each other. Now, if there is a line which cuts these three lines in this fashion, and I suppose this line as x1, y1, and I cut this line as, suppose this x2, y2, and I cut this line as something like this, x3, y3, and I cut this line as something like this, x4, y4. So what is this? These AB, CD and EF, what were these lines? These are parallel lines, and cutting these parallel lines are lines, which lines? x1, y1, x2, y2, x3, y3, x4, y4. So what are these? These are transversal lines. Those lines that cut parallel lines. Now there is a whole lot of concept involved in this concept. This I will cover in the proportionality theorem in my next video lecture. So just at this point of time, you just need to know this thing, that this is transversal line, cutting the parallel lines in a vertical direction. Not definitely in the same angle, but in a perpendicular sense. These were the parallel lines, and vertical to this parallel lines, not exactly perpendicular. You can say that this line forms an angle of 90 degree, but this line can also form an angle of 75 degree. This line can form an angle of 120 degree. So the difference may be there, but any line that cuts two or more parallel lines will be said to be a transversal line. So this is the basic definition of a transversal line. At this point of time, I am just finishing my video lecture here, and in the very next video lecture, I will start from this point only, and I will tell you what proportionality theorem is. So thank you for listening to this video lecture.